Hello and welcome to this video on evaluating square roots of perfect squares. So in this video I have just several examples of where we're asked to find the value of a square root. And in this video also I'm going to talk about what certain symbols mean, what does it mean to be a square root, and what is the meaning of a perfect square. Right. So let's begin. So my first example, and in the first several examples, I'm going to ask myself to do the following. Evaluate, find the value of each square root. Alright, so we'll talk about what a square root is before I get into this stuff over here. This is the square root of 81. We'll talk about that over here real quick. So square roots, alright, and what certain symbols mean. So if x squared, if some number x represents some number, if x squared is equal to y, then we say that x is a square root of y. Alright, so for example, you know, 5 squared, right? Remember what it means to raise to the second power means multiply it by itself. That's 5 times 5. 5 squared is, 25, 5 times 5. So, from what I set up here, 5 is a square root of 25. Right? It is a number that you can square to give you 25. Alright, but also, 5 isn't the only number that you can square to get positive 25. Another example, what if I took negative 5, in parentheses, squared it, meaning negative 5 times negative 5. Well, remember, a negative times a negative is a positive, right? Negative 5 times negative 5 would be positive 25. So, not only is 5 a square root of 25, but negative 5 is also a square root of 25. Alright, and I'm going to make a little note here for you. This is going to happen for any positive number, alright, like 25 or 36, 49, 10, any positive number. Every positive real number has 2 square roots. Every positive real number has 2 square roots. Okay, one positive and one negative. So one positive square root and one negative square root. So like the number 25, 25 has the positive square root of 5, and 25 has the negative square root of negative 5. One positive square root, one negative square root. And every positive number will be like that. So out loud here, for example, 36. The positive square root of 36 is 6, because 6 squared is 36. The negative square root of 36 would be negative 6, because negative 6 times negative 6, or negative 6 squared, would be positive 36. Now that we know this, that every positive number has two square roots, a positive one and a negative one. When you're asked for the square root of a number, which one are you asked for? Are you being asked for the positive one or for the negative one? And that'll depend on what symbols you're seeing. All right, so I'll come back to this square root of 81 in a second, but that'll all depend on the symbolism. All right. All right. So you've probably seen this symbol before and know what it means a little bit. So when you see this symbol here, this is called the radical symbol. All right, this little symbol is called a radical symbol. All right, and when there's usually there's a little number in here in the little jagged edge, the little crook here. When there's no number here, which there isn't right now, where my pen is waving. When there's no number, it's for the square root, right? So the one we're looking at in particular here is for the square root. So when I see this radical symbol, this is the square root of, and I'll just put in some number a in here, right? This is the way this would be said is, the square root of a. All right. When you see this symbol, I'm asked, what's the square root of a? Well, remember, if a is a positive number, do they want the positive square root or the negative square root? Because you don't ask for both, right? When you ask for the value of an expression, when you ask to evaluate an expression, you're only asking for one number. So when you see this symbol, the square root of a, what's being asked for is the positive one or the non-negative one. They want the non-negative square root of a. Right. The non-negative square root of a. Okay? So keep that in mind. Whenever you see this symbol, what your result is can't be negative. Alright? So very often people tend to make a little mistake here. Now I talked about 25 earlier, right? So for example, if you see this here, if I said, what's the square root of 25 equal to, what's on the other side, what this has a value of, is the non-negative square root, the positive square root of 25. Right? We saw that 5 was a square root of 25. We saw that negative 5 was a square root of 25. This is asking me for, when I see this symbol, the positive one. So this is just 5, okay? That's it. Not negative 5, not plus or minus 5. Very often I see the mistake made where people say the square root of 25 is plus or minus 5. And I get why you're doing that, right? Because there is a positive and a negative square root. But when you see this symbol, please get this in your heads. When you see this symbol, you are asked for the non-negative square root, the one that's not negative. Right? Now, if they want the negative one, what if they want the negative one? They'll actually put, you'll see in texts, they'll actually put a negative sign in front of the square root symbol. So if you actually see a minus sign, a negative sign in front of the square root, then they want the negative square root of a. Alright, so back here again, if I said what's the, so again, an example here, what's the negative square root of 25? That's just negative 5. Because again, you could almost eliminate the minus sign. You could eliminate the put your finger over the minus sign and say, hey, again, I'm seeing this symbol, the square root of 25. That's asking for the non-negative one, right? The square root of 25 is 5, and then they want it to be negative, right? You'll see a negative sign in front of the symbol if they want a negative number as a result. But if that is not there, like up here, you are going to have a non-negative result. All right. So please, please, please get that in your head. That is not plus or minus when you see that symbol. All right. Now, one other thing I want to discuss before I get into my examples, one more thing, is perfect squares, right? The title of this video was Evaluate Square Roots of Perfect Squares. So let me discuss what those are. All right. All right, so basically, if a rational number, right, something that can be written as a ratio of two integers, a fraction, if a rational number can be expressed, or can be rewritten, right, can be expressed as the square of another rational number, then that initial rational number we're talking about is a perfect square. Then this rational number is what they call a perfect square. All right, so some examples of perfect squares. So for instance, the number 1, right? The number 1, that's rational, right? You can write that as 1 over 1, a ratio of two integers. This is a perfect square because you can express this as, a rational number squared, or just, 1 squared. Right? So 1 is a perfect square. 4 is a perfect square, right? Because 4 can be expressed as another rational number, 2 to the second power. So I'll just do this down here, right? Our perfect squares are down, this column here. Here are some perfect square examples. Right? So 1 is 1 squared, 4 is 2 squared, 9 is a perfect square, right? Because you can write it as a rational number squared, 3 squared. 16 is a perfect square because you can write it as a rational number squared, right? 4 squared. We saw 25 already, right? 25 is a perfect square because you can write it as a rational number squared, right? 5 squared. 36 is a rational number squared, 6 squared. And again, you could also use negative 6 and squared, negative 5 squared, negative 4 squared, right? Still get positive 16, positive 25, positive 36. 49 is 7 or negative 7 squared, right? But it can be read as a rational number squared. And I'll just keep going over here. 64 can be written as 8 squared or negative 8 squared even. Then 81 can be written as 9 squared or negative 9 squared, but still written as a rational number squared. 100, right? That can be written as 10 squared or negative 10 to the second. 121 is 11 squared or negative 11 squared. 144 12 squared or negative 12 squared. 169 is 13 squared or negative 13 squared. 196 is 14 squared or negative 14 squared. And 225 is 15 or negative 15 to the second power. And I would recommend that you learn the first 15 whole numbers squared, the first 15 positive integers squares, 1 squared up to 15 squared. I recommend you learn these, memorize these. It would make things a lot easier for you. But not only, these are all just whole numbers though, right? Integers. But I said earlier, any rational number that can be written as another rational number squared. All right, so like 1/4. 1/4, that's a perfect square because I can write 1/4 as another rational number, 1/2 to the second power. And go ahead and try it out. Where 1/2 times 1/2 is indeed 1/4. Remember, when you multiply fractions, you simply multiply the numerators, 1 times 1, multiply the denominators, 2 times 2, and you get 1/4. 16/81 would be considered a perfect square, and really it's just the ratio of these other perfect squares, right? You see 16 in the numerator, 81 in the denominator. 16/81, this fraction, this rational number, is a perfect square because I can write it as 4/9, right? Another rational number to the second power. Right? And I could do that forever, right? Just keep writing fractions with all these perfect squares in the numerators and denominators. Okay, so there's what I mean by perfect square, right? A rational expression that can be rewritten as another rational expression to the second power. All right, so finally, after all that discussion, let's go back to my first example, and then I have plenty of them. So here I have the square root of 81. Now remember, this is the positive square root. So what's on the other side is again the non-negative square root of 81. Okay, but please, 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 I can't say this enough. Too many people make these mistakes in the classes I've taught. The square root of 81, yes, I know that -9 to the second power would be positive 81. But this symbol is asking you for the non-negative square root. So what non-negative number, when you raise it to the second power, gives you 81? Right, well, that would be 9. We saw that on the previous page with the perfect squares. So the square root of 81 is 9. And that's it, right? Just 9. Not -9, right? It's the non-negative square root of 81. And you can double check, just make sure that 9 to the second power is 81. Is 9 times 9 81? Yes. All right. So you can always try to verify it by squaring the number you got. Okay, wonderful. All right, so here's a bit of a larger number. Still asks for the same thing, right? So again, I'm seeing this radical symbol, this square root symbol. The square root of 900. So again, this is a positive number, so it has a positive square root, it has a negative square root. But when you see this symbol, you are asked for the non-negative, in this case the positive square root. I'm going to write this out a bunch, right, of 900. All right. So what non-negative number or a positive number, when you square it, would give me 900? And that would be 30, right? And again, you think about it a little bit, right? 3 times 3 is 9. So that would give me the 9. And, adding a couple zeros there, 30 and 30 would give me 900 when I multiply them. So the non-negative square root of 900, or just the square root of 900 here, is 30, right? And again, that's because, right, since 30 to the second power would be 900. All right. All right, but this is the answer, 30. And just 30. I know negative 30 to the second power would also be 900, but I'll say this a bunch, but this symbol means give me the non-negative one, please. Okay. Here is the square root. Again, non-negative square root, right? I'm just seeing the radical symbol there. I'll write it once more. This is asking for the non-negative square root of 9/4. Okay, so let's think. What is a non-negative number? In this case, a positive number that when I square it, multiply it by itself, gives me 9/4. And it's really as simple as, I talked about how, you remember how 9 is a perfect square, right? That's 3 squared. 4 is also a perfect square, right? That can be written as 2 squared. So really you just kind of think of when you're looking at a fraction, you can take the square root of the numerator and the square root of the denominator separately. So the square root of 9/4 is, 3 in the numerator, right? The square root of 9, and 2 in the denominator. Again, positive, not negative. Now, like I said before, I know that negative 3/2 squared is also positive 9/4, but that is not what's being asked for. Pay attention. This symbol gives me non-negative square root. And again, that's because if I were to take 3/2 and square it, you're getting the 9/4. Right? So sometimes people often say taking the square root is the inverse of squaring, right? They like undo each other. When I take the square root of 9/4, I get 3/2, and when I square 3/2, I get 9/4. They kind of go back and forth. You can think of those as inverse operations if you want. Right. So here I have another one. Now this one's a decimal. If you like it as a decimal, fine. Alright, I'm going to stop writing the non-negative thing. Hopefully you see that by now. I'm seeing this radical symbol. There's no minus sign in front of it. So again, I'm being asked for a non-negative number. Something that's not negative here. That when I square it, I get 0.16 or 16/100ths, which is the way I'm going to write it. You can write any decimal as a fraction pretty easily. Just go to what place does this end in, right? It's the tenths, the hundredths place. So this is 16/100ths, or 16 divided by 100. That fraction. Same number. These are the same number. And alright, same as I did with my last example with the fraction, you can do the square root of the numerator, square root of the denominator separately. 16 is 4 squared, so the square root of 16, the non-negative square root of 16 is 4 over, and then the denominator, square root of 100, would be 10, right, since 10 squared is 100. So the answer is 4/10. Now if you want to go back and write that as a decimal, like the original one was, 4 divided by 10 is 0.4, right? It's 4/10, right? End with 4 in the tenths place. So there we go. Or if I left it as a fraction, I would definitely simplify it, right? 4/10 is fine, but they have a common factor of 2. You could have also written this as 2/5, right? Again, this is because, right, since 0.4 when you square it is equal to 0.16, or 4/10 when you square it is equal to 16/100ths. But please, please, please don't write plus or minus. Don't write a negative one, right? When you are seeing, I'm saying this every time, when you see this symbol, your result should be positive or non-negative, because the square root of 0 is 0. And 0 is neither positive nor negative, right? So they include. So when I say non-negative, I just mean 0 or positive. All right. My next example is a little different. We're trying to find the value of this expression. What number is it equal to? And I'll write a little rule here for you. All right. So here I have in parentheses the square root of 13. And then this number is being squared. Right? Okay, so remember what I said a little while back, earlier in the video. I said, remember how square root, taking the square root and then squaring are, inverse operations. I'll write that off to the side here. Taking the square root and squaring, undo each other. Or our inverse operations. And also think a little bit about it. Right? Remember what the square root of 13 means. Now 13 is not a perfect square. Right? It's not like 4 or 9 or 100. Right? 13 is not a perfect square. I can't think of a rational number that I could raise to the second power and get 13 back. But I'll describe this in words, right? If you knew what this was, right? If I knew what it was, what is the square root of 13? It's the non-negative number, right? Because of that symbol. It is the non-negative number that I would have to square to get 13. Right, that I would have to raise to the second power to get 13. Right. And look at what's happening here. That's what we're doing in this expression. We're taking this square root of 13 and then we're squaring it. So the square root of 13, that's the number that when I square, I get 13 back. So the square root of 13 squared is just 13. And I'll write that down here. And that's it. And that's going to happen in general with the square root of a positive number. Right? We'll talk about the square roots. What do we do when we have the square root of a negative number? What if this was the square root of negative 13? What would I do? We'll talk about that in future videos. For right now, we're taking square roots of positive numbers. So yeah, that's going to happen in general. The square root of some number a, where a is not negative, right? A is some number greater than or equal to 0, right? A is not negative. The square root of a squared will just be a. Right? Because again, what is the square root of a? What does this symbol mean? When I take the square root of a, this square root of a is the number that I can raise to the second power to get a back. So what am I doing? I'm raising it to the second power, so I should get a back. Right. Okay. So let's keep that in mind. Again, this is only for non-negative numbers, right? A here and a here. So it's like 13, 13, right? It's numbers that are not negative. All right. All right. So my next several examples, my last few examples, involve some more operations. You have to simplify a numerical expression, and using like your order of operations. I'm going to make a little note about these symbols. So in this particular example, and for the rest of them, I'm going to be again evaluating each expression, find the value that this is representing. What's this equal to? So you see, remember when things are touching and there's nothing between them, like there's no plus or minus in between them, this is 5 times the square root of 9. This is multiplication. So off to the side, one note for you. Your radical symbols, just like any other special symbol like parentheses or brackets or absolute value symbols, you treat them all the same. So you treat the radical symbol like parentheses, right? Like when you're talking about the order of operations, all right? So the radical symbol is this thing here, right? All right, treat that radical symbol like it were parentheses, right? It's a grouping symbol. So when you perform the order of operations, you remember the first start is you start with you can do the PEMDAS thing, or GEMS, I've heard somebody do. You do things in grouping symbols first. You do things in parentheses first. Simplify that number first, and then take the square root. So that's all I'm trying to say there, right? So you simplify expressions inside the radical symbol first, and then take the square root. Okay, so here I have 5 times the square root of 9. So first I go inside my grouping symbols, this radical symbol. Now that number inside there is already simplified, it's just the number 9. Then I take the square root. So this is equal to 5, and again this is times, I'll put a little dot for times. And then what is the square root of 9? Now remember, this is the positive or non-negative square root of 9. And that'd be positive 3, right? Again, don't put plus or minus 3 or negative 3. It's just this symbol means give me the positive one, give me the non-negative one. And what is 5 times 3? 5 times the square root of 9 is 15. And there you go. There's the single value that this expression is equivalent to. Okay. All right. My next example, same thing. Little expression here involving a radical symbol, a square root symbol. So as I said in the previous page, right, you simplify the expression inside the root first, then take the square root. All right, and actually my next 2 examples will demonstrate a big point. So first, the expression inside. Right, that's not simplified. I haven't combined like terms there. It's not a single number. So we have the square. I haven't taken the square root yet, and I simplify. What is 36 plus 64? That is 100. And now that the expression inside the symbol is simplified. Oh, and by the way, something I failed to mention earlier, I apologize. The expression inside the radical symbol is called a special name. It's called the radicand of that expression. All right, it's a fancy word for the expression inside the radical symbol or inside the square root symbol. So here, 36 plus 64 is the radicand. 100 is the radicand. Back here, 9 is the radicand. Right? Anything underneath the radical symbol, anything inside it, is called the radicand. So my apologies. Sorry. So back to my problem. So you simplify what's inside first. Right? 36 plus 64 is 100, and then take the square root. Right? What's the non-negative square root of 100? Positive 10. Right? Because 10 squared is 100. Great. All right. Now let's take a look at how this example compares to my next one. I'll keep it on the same page here. So 36 is the radicand of this symbol. 64 is the radicand of this radical symbol. And see, I'm taking here the square root of 36 plus the square root of 64, as opposed to the square root of 36 plus 64. You see how these are different? This has the square root over the entire 36 plus 64. this has two separate square root symbols, radical symbols, 1 over 36 and 1 over 64. And let's see what we get. Now, well, first I'm going to simplify the radicands, right? Simplify the expressions inside the symbols. Well, that's already done. 36 is already as simple as that gets inside this symbol. So now I just take the square root. What is the square root of 36? Well, the non-negative square root of 36 would be positive 6. And then I have plus, right, the plus sign, and then here we're taking the non-negative square root of 64, and that's already as simple as that gets, right? You can't simplify 64 any further. And what is the non-negative square root of 64? That would be positive 8, right? Because 8 squared is 64. I'm not finished simplifying yet. I don't have a single value yet. And then, now that I've done my grouping symbols, right, my radicals, then, there's no multiplication here, but there is addition. And 6 plus 8 is 14, right? So the value of this expression, the square root of 36 plus the square root of 64, is 14. Whereas when I took the square root of 36 plus 64, I got 10. So this leads me to another mistake people often make. Notice up there that the square root, if I make a big square root of, say, a plus b, right, where a and b are numbers, so like 36 plus 64, like this one up here, is not necessarily going to be equal to, so is not equal to, the square root of a plus the square root of b. Right? And again, a perfect example to show this, and this is huge, please know this, please remember that you cannot just split up the sum. Alright, if you have the square root of a sum, you can't just split it up and take the square root of each term. And you can see that from this example right here. The square root of a plus b, where a is 36 and b is 64, up here is 10, but the square root of a plus the square root of b, right, where a is 36 and b is 64, in here is 14, not 10. They're not the same. So please, 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 when you see a sum underneath a square root symbol or a radical symbol, do not split up the terms. Do not distribute the radical symbol. Okay, hopefully that example with the 36 and the 64 made that a little clearer. Alright, and then my one final example. It's another radical, right? Another square root, as all these have been. But there's a more complicated expression inside with some numbers. And this is something the reason I'm putting this example up is because you'll be seeing stuff like this, radicals with expressions like this inside, when you solve quadratic equations using the quadratic formula. But again, that's for a later video. Alright, so as I mentioned, first I want to take the radicand, right, the expression inside, and simplify that first. And then take the the square root, or find the non-negative square root. Alright, so remember your order of operations. This is 25 minus. You don't do there's multiplication here. You do multiplication before you do any subtraction or addition. Alright, so this is equal to the square root, and I'll take this one step at a time. You got the 25 there, didn't do anything, minus, and then I'm multiplying a bunch of stuff here. 4 times 3 is 12, and 12 times negative 2 is negative 24. So the 4 times the 3 times the negative 2, that's negative 24, and we are subtracting that, right, from 25. Now hopefully you remember this too, that subtracting is just like adding the opposite. So subtracting a negative is just adding a positive, right? Subtracting negative 24 is the same as the square root of 25 plus 24. Alright, still not done simplifying in here, still have the addition to do left. So that's the square root of 25 plus 24 is 49. And that's a nice perfect square, right? Again, go back to that page I was writing with perfect squares. 49 is one of those that can be written as 7 squared. or negative 7 squared, but remember, when I see this symbol with no minus sign in front of it, I'm asked for the non-negative square root. So the square root of 49, right, the non-negative one would be positive 7, right, since 7 squared gives me 49. Right? So the answer, right, the final result is this positive 7. So this crazy square root up here has a value equivalent to positive 7. All right, great. So hopefully you learned some lessons there. You know, what does the radical symbol mean? And when you see it, this square root symbol, please know that you're being asked for the non-negative root, not the negative root. Right? Also, that this one is huge. I want to bring this one back. Please try not to make this mistake. This is huge right here. The square root of a big sum is not the sum of the square roots of each term. You don't split them up. Please. All right, that is a huge mistake I see people make way too often. So I'm going to keep that up here while I do my last little spiel. All right, and I like to say at the end of these videos, try the best you can, do the best you can to learn the material on your own before you go looking for help. Because I find that people who take the time and the effort to learn things on their own tend to remember it better, and also remember it for longer, and feel more confident in themselves. And so, read the material, of course. Read through the author's examples, perhaps even try to work out some examples, solutions to some examples before you even look at how the author did it. And then compare your work to the author's and see if you can learn from any mistakes there. Obviously, you should also work on plenty of exercises, plenty of practice problems. Look up solutions whenever they're made available so you can check yourself and keep track of your progress. And don't just give up after the first attempt at a problem. Very often in mathematics, there are several approaches that'll work for a particular problem. So if after several approaches at a problem, several ways of trying to do it, and you're still not getting it, still not seeing how it can be done, still not understanding the material, perhaps you should go back and read the material again. Maybe even a third time. Read it more slowly, more deliberately. Take notes. And also, if you've been working on problems for a little bit, you probably have a better idea as to what the author wants from you, what the author is expecting of you. So you'll also have a better idea as to what to look for when you go back and read again, right? And what to look out for, and and perhaps on that second or third read through, some things will click in your head that didn't the first time through, and it'll just make it that much easier. Now, of course, if after these several read-throughs of the material and several attempts at problems, you're still not getting it, well, then it's not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos on the subject, such as this one, or the plenty of videos out there that are better than mine. I'm sure that they're out there. I know that they are, and you can easily find them. But just keep at it is all I'm saying. Stay persistent. Keep practicing. And I think the hardest thing to do too is try to have a positive attitude about the subject. Go in with an open mind and say, I'm going to read this today, I'm going to practice these problems today, and I'm going to learn something, I'm going to enjoy it, I might even have fun with it. I know it's easier said than done, of course. Many people don't really care for mathematics or think it's boring, but you'd be amazed at the difference a little change in mindset can make to the learning experience. So please, stay persistent, keep practicing, try to have a positive attitude, and just don't give up. And I believe, I just know you can get it. And thank you very much for watching.